Hi friends, have you ever thought why do commercial aeroplanes fly between 30,000 to 40,000 feet range? Why not below this? Why not above this? What's the reason actually? Why? Why? That's the question. So let's understand that. Now the first we will understand what we want from our commercial plane. Okay. So first thing is simple. It should not hit the buildings, mountains. Okay. Otherwise we will not be able to reach the destination. Second is it takes less time to reach the destination. Third, it should consume very less fuel as much as possible. Okay. So these are the three things that we want from the any commercial plane. Question is how they are helpful in deciding whether we should fly at 30,000 to 40,000 feet or not. Let's tackle one by one. The first one is it should not hit the buildings or mountains. We don't want that our aeroplane should hit these glass buildings or any kind of mountain. So, what the Federal Aviation has done, Federal Aviation Regulation has created called a minimum altitude, okay, of any kind of obstacle that you can fly, and that thing we call lowest safe altitude. So this is the altitude, okay, above which you can fly the aeroplane so that you don't hit any kind of mark building. So let's say any kind of obstacle that you have around 500 feet, you should take 1000 feet extra for that. So let's say this is the number that is given here. This is the 1000 feet. So you are getting 2460 feet. That means above this number only you are able to fly the airplane so that you don't hit any building. Okay, that is the first criteria that is required for flying the airplane. Hence, first is aeroplane should fly above the lowest safe altitude, at least 1000 feet above any obstacle. That's the first condition. Second condition, it should take a less time to reach the destination. So, in order to reach, imagine this is the road that is given to us, okay, or we want to basically move our vehicle, wheeler, three wheeler, any kind of vehicle, you can easily reach because there is no potholes. Compare with this. Which one you think you will go faster? You will take less time. Obviously, you will say the first one, isn't it? Because in this there are no potholes, there is no obstruction. Now the next question comes, what disturbs the aeroplane? What is the obstacle for the aeroplane? In order to understand this, we need to see what is happening in the air, what is there in our atmosphere. So if you see, this is the surface of the earth. And then above that you see you get a troposphere, which is one of the atmospheric layer. Above that you have a stratosphere. Now in these two layers, you see a lot of turbulence of the air is there. Why? Because there are clouds, mountains, birds are flying, wind velocity is there. There are so many phenomena are happening. So because of those are the disturbance for the aeroplane. Now imagine you are flying an aeroplane and this is the turbulence of the cloud around you. You think you will be able to go in this turbulence with a maximum speed? No, you have to reduce your speed, isn't it? It is like the potholes on the road. Similarly, these are the potholes for the aeroplane in the air. Now the question is, then what should we do? How can we increase the speed? How can we reduce the time so we reach the destination faster? So scientists have basically created a chart of the environment to understand which region the cloud are very less because they are the most disturbance. So you see this cyan color. In this cyan color you can see above 30,000 feet you see the very less clouds are there. This is you are out of cloud. Okay, so this chart clearly show that we should actually fly above 30,000 feet at least so that you get a less turbulence, you reach faster. Okay, so that's one of the reason. Now it should take less time to reach the destination. Airplane can flow above 30,000 feet with minimum turbulence. That's the second reason why we fly. Now the third important reason, we should consume the less fuel. When we are talking about the glass fuel, what's the meaning? Meaning every single drop of the fuel should be utilized, isn't it? We should reduce as much as fuel as we can. Now, so when you say efficient, what is the meaning of efficiency? So the engine that fly the aeroplane, we call that as a jet engine. So that engine should be very, very efficient. And we define a term called a thermal efficiency. Question comes, what is the thermal efficiency is? It's a simple thing, nothing but how much is the output you are getting based on the provided input. If you are giving the 100 joule energy from the fuel, aviation turbine fuel, then how much energy you are getting as an output? Ideally, we want this energy should be 100%, but it doesn't happen. So, this is basically the efficiency of a conversion of heat energy of the fuel into the kinetic energy of jet stream. You can see the jet stream is coming like this. This is the jet stream. So, what are the fuel that we are giving? How much velocity we are getting because of which your airplane is flying. This is how we define the thermal efficiency. Now what we want from this thermal efficiency, this should be as maximum as possible. Question is, do we utilize fuel with this 100% efficiency? We have the 100% efficiency. So what is the entitlement of efficiency? Let's understand that. So there was a scientist called Sadi Carnot. Around 1800 time frame, he gave a law we call Carnot law. Based on that, he defined that any jet engine can have the or any kind of thermo engine acquire the maximum efficiency only operating between the two temperature range. Its efficiency depends solely on the minimum and maximum temperature in which that engine is operating. And this is the formula by which you can evaluate that. Now, if you closely observe this formula, okay, this is if you closely observe this formula, here what we want, this term, T cold minus T hot. Ideally, we want this should be 0. So that we get a eta is equal to 1. That means 100%. We want this term should be 0 as possible. But you cannot get T cold as 0. T cold 0 means 0 Kelvin. 0 Kelvin is not achievable in the atmosphere, isn't it? We don't have the temperature in the 0 Kelvin. Now the question comes, how we can reduce this? That's our target. T cold by T hot, we want to reduce as much as possible. In order to reduce this quantity, what should we do? Like mathematics, numerator should be reduced and denominator should be increased. That's our target should be. So that this quantity will be reduced as much as possible. Okay. Now let's see how we can do that. First we will discuss the T hot. T hot is this. If you talk about the T hot, we want to increase this amount so that this total amount decrease. In order to increase, who limits? If you see, this is the typical cross section of jet engine. Okay, you can see like here the temperature is increasing as you go from front to middle, then decreases, and this is the maximum where the combustion is happening and it is going to the nozzle, first stage nozzle. Here the temperature is very high. Now this first stage nozzle or this is made up of some material, some metal, some alloy that also have the melting point. So it means the maximum temperature you can increase below the melting point. Otherwise that material will melt. It will not function. So basically the maximum temperature that you can have is purely dependent upon the material capability or simply the melting point of that. Okay. So now the next thing comes, aeroplane if we think about it can operate maximum at 2200 Kelvin or 1930 degrees centigrade with the current available material technology. This is the simple chart. Okay, from the research gate you can clearly see the temperature is in the range of 2200 Kelvin. Okay, so beyond that We have not got any kind of material capability that we can utilize. So that means this is our entitlement of the maximum temperature, and this is achieved in the turbine nozzle in the jet engine. So now the question comes, how hot this temperature is? Is this a very high temperature? Let's see few numbers. It is a really high temperature. We know ice cube melts at 0 degrees centigrade. You have a um, dry CO2 ice cube. When you put at 0 degrees centigrade, it converts from solid to liquid. It is melting. Iron is the very hard, very strength metal which can melt at 1535 degrees centigrade. Our bone, which is basically a calcium carbonate, okay, it melts at 1670 degrees centigrade. We are operating our metal at 1930. Oh my god, that means your bone can get fire. Bone can melt at that point, isn't it? This is the technology. That's why it's exciting. So that means these are very, very high temperatures. Now the question comes then, how to increase the efficiency? Again, this hot it can be increased till the melting maximum point. This is the limitation. We cannot increase beyond that. Now T cold. Can we do something with T cold? Can we reduce this T cold? Is that possible? T cold is the minimum temperature in which the aeroplane is operating. That means it's an ambient temperature. In order to understand that, we need to see the atmosphere. If you see the atmosphere, we have a many layers. We have a troposphere, stratosphere, mesosphere, thermosphere. Question comes, how the temperature vary in this? In order to reduce this T cold, we should observe this. See how the pattern is happening. It is decreasing, then becomes straight, increasing, straight, decreasing, straight. Oh my god, that means as you go above the surface of the earth, our temperature is doing zigzag motion. Question is, then where should we fly? Where we will get the maximum efficiency? Okay, let's give some numbers. These are in kilometers. So if you see 1 kilometer is 3281 feet. 10 kilometer is how much? 32,801 feet. That means in this range. 12 kilometer somewhere here in this range. That means this is the range that we were telling the airplane flies. Question is why? You get some clue. Temperature is less. After that the temperature is increasing. We will not get the efficiency. So if you see this ambient temperature, it is decreasing from the Earth's surface to the 12 kilometer. It is continuously decreasing. It is 39,000 feet in troposphere. After that we get a tropopause. It remains stable or more or less 12 to 20 kilometer. Okay, this is the tropopause, and then after that it is increasing 50 kilometer, 65,000 to 1,64,000 feet in stratosphere, and then stratopause. That means we can take the advantage of the maximum efficiency till tropopause. So here we can fly the aeroplane. That's the maximum thing. That's why we fly the airplane in this troposphere, in this region. Okay, 12 kilometer range up to 12 kilometer, 30,000, 35,000, okay, 40,000 feet. Up to that only we fly. Now the next question comes, can't we fly beyond that? It has never been done? Answer is no. This is basically our supersonic Concorde. This flew at a maximum cruise altitude of 60,000 feet in the tropopause with more than twice the speed of conventional aircraft. Okay, now this airplane has been retired. This engine has been retired from that. Okay, now so for all the commercial plane we fly till 40,000 feet maximum. So from this what we have learned, our commercial plane fly between 30 to 40,000 feet. Why? Because they should not hit the building. Why? It should take less time to reach destination. Why? They consume less fuel in that range only. That's the main reason. Hope you know now. Why do commercial airplanes fly at 30,000 to 40,000 feet range? Thank you for watching. If you like, please comments on the comment box. Thank you.